talk about, yeah, now we are going to talk about functional from, thank you. Now we are going to talk functions of several variables. So far in your A-level classes, you learned functions of a single variable, real functions, right? So now we will discuss functions, function. We will discuss functions of more than one variable. Earlier you had like this, one independent variable. This time you have more than one independent variables. Y, x, y, z, like this. Yeah, this is called function, a function of several variables. Right? These all x, y, and z are independent variables. So, right, these are a couple of first, do you know what a function is? So, function is a relationship between two sets. So I briefly mention what a function is. Yeah, it's a mapping from A to B. Yeah, so you have set A and set B. So it is a relationship between these two sets. If it is a function, so each element in this set should be mapped into other side. Each element, right? So when you, yeah, when, so yeah, so this each element should be mapped into a unique element in set B, unique element. That is very important. Otherwise it is not a function. This is not a function. This is not a function. So yeah, this is not a function. If you want to define a function, so each element in set A should be mapped into a unique element in set B, right? So this is called domain of the function. Let's say this, let me define. So this is the function from A to B. So, all right, okay, yes. So yeah, function from A to B, A set A. So we are giving a name for set A. Set A is called the domain of function. So yeah. Domain of function F, and this is called codomain. Yeah, so like that. Yeah, so you learn. I think you learn details in pure math courses. So I don't have time to discuss those things. I think we have only 7 weeks to cover this up. Yeah, so I will, just moving to this. So these are a couple of examples of functions of several variables, right? So how do you find, so if you, so actually this is a function from where to where. These are real functions, right? So this side, this set, what is the set? R cross R. So this is your set. This is your left hand side set, and this is your right hand side, because this is a real function, and that, so there's a relationship between these two. So the relation is defined in this way, and so each point in this point, each element in this set is mapped into a real number like this. So in this case, you all the time get non-negative number, because here you have sum of squares. So square is always non-negative. When you add non-negative numbers together, you get another non-negative number. Yep. The range is all non-negative numbers with zero. If you plug 0, comma 0 into here, then you get 0. Output is 0. Yeah. So like that, you can define function and you can define the maximal domain. So maximal domain of this function is r cross r, or you can write this one is r squared. Yeah. So this is a function from r squared to r. Yeah. So the domain of this function is r squared. Yeah. The range or image is all non-negative numbers, not negative numbers, non-negative numbers. Right. That's right. Make sense? Any questions? Yeah. So this is how you find output. Yeah, very easy. Easy. Yeah, sum of two. Yeah, sum of two several function would be another. Yep. Yeah. Yeah. So yeah, this is basic. Yeah, sum of two several variable function would be again a function of several variables. Yeah, a product of two several. Yeah, product. Yeah, again a function of several variables. Yep. Yep. So let's find the domain now for these kind of functions here. So the domain, the maximal domain, definitely domain is a subset of R2, right? So because here, if you look at this function, so this is not defined for negatives. You know that if you are talking about real functions, what if this guy is equal to negative number? So this is not defined. This would be a complex number. So if you want to define, if you want this g function g to be a real one, so this should be positive. X, y should be positive. If one of these is equal to 0, whatever we get trouble, right? So if your denominator is equal to 0, yeah, it is undefined in our world, in real world, right? So 1 over 0 is not defined, so you have to exclude those cases. X is not equal to 0 or y is not equal to 0. Both either x or y is not equal to 0, right? Otherwise denominator becomes 0, right? Okay. No, f of x comma is not how we take here this definition. Yeah, this if you have two several variable functions, you can define some of these two functions as so I will write in vector form, right? Because this is a vector, two-dimensional vector. Now this is same with f. So this is a definition. Definition. F of x vector, right? So because this so writing this whole thing is tedious. That's why I use this vector form, right? So I don't let's say if sometimes you may get confused when I use x, I will use another character alpha. Alpha, vector alpha. Yep. So this is how we define the sum of two several variable functions, and you can define the quotient like this, quotient as well as the multiplication of. Okay, right. So let me discuss how do we define the domain. Yeah. For instance, yeah. So domain of this one, no problem. Domain. What is the domain of this? Maximal domain is the entire xy plane. That means R2, right? That domain is R2, entire real xy plane. So what is the domain of this? If you want this to be real, yeah. So what is the domain of this? So 1 over 0 is not defined in our world. So we have to avoid that case. And if this is negative, yeah, so then this becomes a complex number. So how do you define the domain of this function? What is the domain of this? Yes. Yeah, anyone? Yes. Domain would be no. So actually domain of this function is a subset of R2. R2 is your XY plane, entire XY plane. So you have to exclude some points from this plane. So you have to exclude, yeah, so X there. So X, Y should be. So let me draw. Let me write down the domain of G is a point in XY plane, X comma Y. This a point in XY plane such that X times Y should be positive. Got it? Otherwise, you cannot define this to be real. Yep. So if you want to define this function precisely, so you have to, yeah, so this term should be positive. If this product of X and Y is negative, what happens? This becomes a complex number. Yep. So this product should be positive. Yeah, so then you can exclude. Yeah, so then this is so make sense? Does that make sense? Yeah. Cannot we write domain as domain is right hand side. So this is your domain and this is your codomain, and relationship between these two sets is called the yeah, we label this relation as f. If this is a function, as I said before, each element in the domain should be defined, right? And it should be mapped into a unique element in this set. And if you want to define, yeah, this I think for this function, for this one is no problem because here you have x squared and y squared, right? So this is defined, you can define as a function for entire xy plane for this one. But here when you define this one as a function here, so you know that, so we don't talk about this number, right? 1 over 0. When the denominator is equal to 0, yeah, you never talk about this number is 1 over 0. So you have to avoid that case, as well as the other one is, other one is, so this should be a real function. If it is a real, then this product should be positive. Otherwise, this becomes a complex number. Okay. All right. So therefore, so domain, the maximal domain or domain of this function is an element in xy plane. This is your xy plane, right? This plane R2 is your xy plane, right? So such that this product should be positive, right? Let's do another example. Okay, this one here. So what is the domain of this function? Okay, so let's visualize this. Okay, this is a square. Okay, so you know the equation of circle. Sorry. So this circle center at the origin and the radius is 5, right? Okay. So when you plug this point into the function, yeah, so 0, 0. So then square root of 25 is 5. Yeah, that's nice. So then when these negative terms is minimum, negative terms are equal to minimum number, right? What is the minimum of this one? Is 0, right? So this is a square one and this is another square. So minimum of this guy, so because here x squared. So this is the minima. Minima occurs at 0, right? And this one also same. Yeah, then the function value becomes the maximum. Yeah. Yeah, this is x, y, and z equal, yeah, this function f of x comma y. Actually, this is a three-dimensional surface. Yeah. Yep. So here you have a circle. So yeah. So inside this circle, what happened? Yeah. What happened? Yeah. On this circle, x squared plus y squared is equal to 25, right? On this circle, right? So inside this circle, yeah. Yeah. So if you consider any point inside, right, of this circle, this radius is less than this radius 5, right? Okay. Or if you plug this point into this one, then you get a positive value here, right? This one is positive, right? So then when you take the square root, then you get another positive value. This makes sense. If you plug a point which is outside from this circle, let's say, yeah, let's plug this point here. This is, yeah, so let's plug this point 6 comma 0. X coordinate is 6, y coordinate is 0. So definitely this radius, what is the radius? This is this one is 6, this length is 6. This the radius of the circle is 5. This point definitely outside from this circle. Okay, so if you plug this point into this function, so what happened? Yeah, 25 minus 6 squared, which is 36, negative 36 minus 0. So this value becomes negative. Then you get a complex number when you take the square root, right? So outside points of this circle is not defined, so that this function is real. If you want to define a real function, so you have to consider the all points inside, on or inside of the circle. So if you want to define this to be a real function, so then you have to consider all points on or inside of the circle. So this is the domain. So this is a subset of this xy plane. Xy plane is this infinite plane, your computer or infinite plane, right? This yellow one is a subset of that, right? So for this set, this function is defined nicely, right? For this set, this function is defined. For other points, this function is not defined as a real function, right? So this is the maximum domain. So this all points inside and all points on the circle and inside of the circle. Yeah. So that's the highlighted area is the domain of F. So this is the maximal domain, right? So how do you write? So domain of F is, let's take a general point. So general point in this plane, xy plane. Yeah, such that what is the relationship between x and y? What is the relationship? Such that if you consider any point xy in xy plane, the relationship, that one x squared, if you compute x squared plus y squared, so this length should be less than or equal to 5. 25. Okay, makes sense? So this is the domain of this function, maximal domain. Make sense? Does that make sense? Let's look at another example. This time a function of, this is g is a function of 1, 2, 3 variables. Yeah. What is the domain? Yeah, what is the domain of this function? Actually, yeah. So can you tell me the domain? Yeah. Domain of G? Yes. Hurry up. Can you unmute and one of you guys? Yep. Can you tell me? Yeah, Prabhav, yep. So are you there, Prabhav? Yeah. So what is the domain? So domain, yeah, so here x, y, z. Yeah, x, y, z. And other axis is, yeah. So we cannot draw that. So very hard to visualize this four-dimensional. Yeah, this is a four-dimensional functions. So this is a four-dimensional function, really hard to visualize, right? So yeah, let's so domain. Let's consider one of points points in this space. X, Y, Z is a point in three-dimensional space such that if you want this to be real, so inside term should be greater than 0. That's all. X squared plus Y squared plus Z squared. I will take this term to other side. 16, 4 squared. Yeah. If you draw this area, so if you draw this this one, this is a sphere. So three-dimensional geometry of this circle is a sphere. Yeah, sphere. So what is the center is the origin, and the radius is 2. 2 is the radius. So if you want this G to be real, you have to pick a point which is outside from this sphere. Yeah, that's right. Yeah, that's good. Yep. Good. Yes. So I'm getting a lot of answers. Yeah, they were, yeah, correct. Yeah. That's right. Like that, you can find the maximal domain for a given function. Yeah. For instance, this one. Yeah. So find the domain of this function. You know, yeah. So let's find. Okay. Domain of H. This time, yeah, you have two variables. Yeah. Domain is a subset of xy plane, that is R2. So take a point, x comma y, pick a point. So how do you pick this point? So what is the relation? Should be between x and y. You have to pick a certain point. You don't pick all points because here you have ln function. You know that ln is defined for. So if you talk about if you are, so this is x. This is one-dimensional ln function, right? So you know that ln. If you want to define ln, so ln is defined for positive values. Therefore, x, y should be positive. Yeah, good. Yeah. Yes. So this is the maximal domain if you want this h to be real. Yeah, that's good. Yeah, positive infinity. Yeah. That's okay. This is also correct. This one. You don't mention infinity because here, so here y, yeah, so x comma y belongs to r cross r. So don't mention this. Yeah, mention the lower bound. That's all. Yeah. So mention this restriction. That's all. So you don't need to put the positive infinity. No need. Don't need this part. That is trivial because, right? Okay, here we go. Yeah, yes. So this is the domain. This first quadrant and the third quadrant. First product of this one is positive, product of negative, positive. Yes. First and third. So likewise, you can define the maximal domain. Find the domain and range. Yeah, domain, yeah, definitely inside of the circle, centered at the origin with the radius r5. Yeah, inside, yes. And the range, what is the range? Yeah, let's visualize this. So we identified so because this is three-dimensional surface, Yeah, we can visualize. So this is four-dimensional surface, hyperplane. So very difficult to visualize. For instance, yeah, this one. So this is four-dimensional, yeah, curve, yeah. Since this is two-dimensional one, yeah, we can visualize, yeah. Yeah, we are able to. So humans can visualize, yeah. So we don't know about animals. I think they have many sense to many dimensions. For humans, we are sense up to three dimensions. Yeah, very much. But give me a second. Give me a Okay, we are able to visualize this because it is three-dimensional surface. So we identified the domain, maximal domain, which is a circle, all points inside of a circle centered at the origin with the radius r. Inside, not only inside, on the circle, because square root of 0 is defined, yeah, on the circle as well. Yeah, square root of 0 is defined. Yeah. Okay, this is the domain. Domain is a subset of xy plane. Yeah, so this is your domain. If you want uh, if you want to define this function as a real function. Yeah. Yep. So on this circle, yeah, the radius is 5. That means xy squared is equal to 5. Then when you consider this one, then this, yeah, the function value vanishes on the circle. Yeah. So at the origin, at 0, 0, the function takes the maximum value, which is 5, yeah, like half sphere. So this shell is the function, half of the ball, yeah. So this one, yeah. So like that, yeah. Did they wish draw the? Yeah. Here we go. Yep. So this one here, this is x. I will x, y, and this is your z, the function x, comma y. Yeah. Yeah, this is the domain. Yeah, maximal domain. Yeah. So all points in or on the circle, inside of the circle, in or on the circle. On the circle, the function value is 0. Inside, yep, so you can find the function value. All right. Now, yes. Where's that? Yeah. And then we can see the range. So what is the range of this? We identified the domain of that function. So what is the range? Range from where to where? From, yeah, range, yeah, 0 to 5. Yeah, 0, this is the range of the function. Up to 5, yeah. The function value, maximum value is 5, yeah. So this is in this range, yeah, you can find, yeah, corresponding x and y. If you slice off this surface, here this is a surface. So let me zoom in a little bit. Yeah, this is a surface. Yes. You can slice off this surface from different places. So I slice off this surface parallel to OXY plane, right? I chop off this surface, which is chop off in the direction that is parallel to OXY plane. So Yeah, so then I get different level curves. So I will explain that in a minute, right? So where's that? Let me check your level curves. Yeah, so yeah, I will discuss that in a minute, yeah, in next slides. So okay, what is this? This is z equals 0. Yeah, let's go through this. Okay, yeah, different level curves. Okay, when you chop off the surface parallel to xy plane, so you get these kind of circles, small circle. When you chop off from here, the height is 3. This is the height, 3. When you chop off this surface, then you get a circle like this. Okay, yeah, like this you can. Yep, I will explain that in next slide. This is another of uh, example of a function of several variables. So this is sine of this one here. You can see ripple effect at the origin here. So limit. So I think limit as x comma y goes to 0 0 of this function is 1. You can go to GeoGebra, you can visualize these. Yeah. Okay, sketch this one. Yeah. Again, yeah. So let me check this. Yeah. Let me talk about level surfaces, level curves, level curves. All right. So, so we are able to visualize objects up to three-dimensional space, right? Three-dimensional objects up to three dimension, one dimension, yeah, straight line, two dimension, this infinite plane, yeah. So then, yeah, we can visualize that this one, and three dimension, yeah. So objects in three dimensions, yeah, we can visualize. So we don't have sense to visualize higher dimensions, all right? So all right, so let's talk about three-dimensional surfaces. Okay, so first of all, let me discuss this surface, which was discussed earlier, right? Yes. All right. So okay, where's that? Yeah, here we go. Yeah. So this is the surface we are going to discuss. The surface, what is the equation of that surface? Yeah, square root of 5 squared. Yeah, square root of 5 squared minus x squared minus y squared. Yeah, the surface, right? Surface. You cut off this surface. Yeah, cut off. Yep. So we select. Yeah, we pick a height from OXY plane, right? Yeah. So let's consider this height. Height is 3. Yeah, this height. So we chop off this surface into 2. How do we chop off? Yep. So how do we chop off? When you chop off the surface to the which is parallel to how do we chop off? How do you say this? I cut this surface into 2 parallel to OXY plane. Okay, then when I cut the surface into 2, then I get this circle here. If you change this height, you can chop off the surface, right? Then, so when you vary this height, you get set of circles like this here. So these are called level curves. So these are called set of level curves. Yeah. So I change the height. So height is 5. So we only get 0, 0. I reduce the height. Height is 4. Then we get a circle centered at the origin, and the radius is 3. And we reduce the height. Yeah, so we get a set of circles like this. So this set of circles, or this set, is called the level curves. Level curves of that three-dimensional surface, right? So this is the level curve of that three-dimensional surface. So give me a second. Someone has. Yeah. So we are going to discuss this example here. So this time again we have a three-dimensional surface, right? X squared plus y 2y squared. All right. So let's sketch a contour map. This is called contour map. The set of levels curves is called contour map. Okay, right. So at 0, when you chop off this surface from here, you get 0, 0 point. From this is the height is 2, and then chop off from then you get a like what is ellipse? Ellipse. Yeah, so this kind of set of ellipse, right? So this is the contour map, uh, of this surface. When you chop off from different height, you get different ellipse, infinitely many ellipse, right? Okay. Yeah. So sketch. All right. Oh, yeah. So I don't have time to explain this bit today. Yeah, there's a bit. Yep. Any questions related? Sorry. Any questions related to? So related what we discussed so far about functions of several variables. Yeah. Next week. Yeah, that means next week you have a spark test, or you have a small exam. It takes only 15 minutes to answer those questions. You are given 5 questions. I think you don't need to prepare for that. If you complete all quizzes, it is related to basic stuff. How do you find cross product, dot product, scalar projection, and so on and so forth. Yeah, very easy. And the next exam, you will get these questions as well. So prepare for those things by going through. If you have any questions, that's why. If you have any question, you can ask now. I want to see your progress, whether you understood the content, and yeah. Any questions, any doubts? I will stop.